Hello everyone, and welcome. I'm excited to have you here today. Today, we'll be exploring an essential topic, water resources. Our presentation is titled Water Resources, and we'll also touch on some key aspects related to this vital subject. We'll cover things like the importance of water, current challenges, and ways we can manage our water resources effectively. So, let's dive in and learn more about this critical issue together. Today, we'll be exploring rainwater harvesting, a vital practice for addressing water scarcity and the urgent need for effective water conservation and management. Water resources are the foundation of our ecosystems and human life, but they are under increasing pressure. One innovative solution we'll look at is the bamboo drip irrigation system, which offers a sustainable way to irrigate crops efficiently. We'll also discuss multi-purpose river projects and the importance of integrated water resources management, which aim to optimize water use across various sectors. To understand the scale of the challenge, we'll review some key some facts and figures, highlighting why these initiatives are so critical. This slide covers the main topics that will help us grasp the complexities and solutions related to water management in our ongoing journey towards sustainability. Let's take a closer look at some innovative water management solutions, starting with the bamboo drip irrigation system. This is a sustainable and cost-effective method that uses bamboo pipes to deliver water directly to plant roots, minimizing waste and improving efficiency. It's especially useful in rural areas where resources are limited. Next, we have rainwater harvesting. This technique involves collecting and storing rainwater for later use, reducing dependence on groundwater and other sources. It's a simple yet powerful way to conserve water, especially during monsoon seasons. Moving on, there are multi-purpose river projects and integrated water resources management. These initiatives aim to optimize the use of river systems for multiple needs, like irrigation, drinking water, and hydropower, while maintaining ecological balance. It's about managing our water resources holistically and sustainably. Now, let's discuss water scarcity and the need for water conservation and management. As demand for water continues to grow due to population and industrial development, scarcity becomes a serious concern. Effective conservation and management strategies are crucial to ensure water availability for future generations. Finally, I want to highlight some key facts and figures about water and water resources. Understanding these numbers helps us grasp the scale of the challenge and the importance of our efforts to protect and sustainably use our water resources. Did you know that about 3/4 of the Earth's surface is covered with water? But here's the interesting part. Only a small proportion of that water is fresh water that we can actually use. Most of this fresh water comes from surface runoff, like rain that flows over the land, and groundwater, which is water stored underground. Both of these sources are continually being renewed and recharged through a process called the hydrological cycle. This cycle is crucial because it ensures that water keeps moving and replenishing itself, making water a renewable resource. So, even though it might seem limited at times, the cycle helps maintain a balance and provides us with the fresh water we depend on every day. Connecting this to our overall theme, understanding how water is renewed highlights the importance of preserving and managing our water resources wisely. Let's take a closer look at some key facts and figures about water. First, India's total renewable water resources are estimated at about 1,897 square kilometers per year. That's the amount of water that naturally replenishes in our country each year. Now, when we consider groundwater, less than 30% of the world's total is stored underground in aquifers. Groundwater is a vital resource, but it's limited and needs careful management. Globally, only about 2.5% of all water is freshwater, which is the type we can use for drinking, agriculture, and industry. However, most of this freshwater is stored in ice sheets and glaciers, around 70%, like those in Antarctica, Greenland, and mountain regions. Speaking of the world's water, approximately 96.5% exists as ocean water. This vast volume of ocean water is not directly usable for most purposes without desalination. Focusing on India, we receive nearly 4% of the world's total precipitation, yet we rank 133rd worldwide in water availability per person per year. This highlights the importance of efficient water use and conservation. Looking ahead, by 2025, projections suggest that large parts of India could face absolute water scarcity, joining other regions globally that are already struggling with water stress. Understanding these facts underscores the critical need for sustainable water management, especially as our demand continues to grow and climate patterns evolve. Water availability changes across different regions and times, mainly because of seasonal and yearly variations in rainfall. However, most water scarcity issues aren't just about natural factors. They're often caused by overexploitation, excessive use, and unequal access among different social groups. When populations grow, so do the demands for water, not only for drinking and household needs, but also to produce enough food. To meet these needs, we tend to overexploit water resources, expanding irrigated areas and engaging in dry season agriculture, which puts even more pressure on our water supplies. The situation worsens with the rise of industries, which are major water users and also require significant power, often derived from water sources. In India, for instance, hydroelectric power accounts for about 22% of the total electricity. Unfortunately, many of our rivers, especially the smaller ones, are now toxic, and even larger rivers like the Ganga and Yamuna have become far from pure. This entire ecosystem and the life it sustains are under serious threat. That's why water conservation is so crucial, not only to protect our health and ensure food security, but also to sustain livelihoods and preserve our ecosystems. Managing our water resources wisely is essential for a sustainable future. Dams serve a variety of purposes beyond just irrigation. They are crucial for electricity generation, providing water for domestic and industrial use, controlling floods, offering recreational opportunities, facilitating inland navigation, and supporting fish breeding. Historically, dams were mainly built to impound rivers and collect rainwater, which could then be used for irrigating agricultural fields. Over time, the concept has evolved to include multi-purpose projects, where different functions are integrated into one system. However, in recent years, large dams and multi-purpose projects have faced significant scrutiny and opposition. One major concern is environmental impact. Reservoirs created on floodplains can submerge existing vegetation and soil, leading to their decomposition over time. Social issues also come into play. Often, local communities are required to give up their land, livelihoods, and access to resources for the greater national good. This has led to protests and social movements demanding fair compensation and consideration. Another point to consider is how irrigation practices have changed, shifting cropping patterns toward water-intensive and commercial crops, which can put additional pressure on water resources. Interestingly, dams meant to control floods sometimes end up causing floods themselves due to sedimentation filling up the reservoirs. Looking back historically, archaeological and historical records reveal that from ancient times, humans have constructed sophisticated hydraulic structures, stone rubble dams, reservoirs, embankments, and canals, to manage water for agriculture and other needs. Finally, modern multi-purpose river projects aim to integrate water resource management comprehensively. These projects are designed to maximize benefits, but they also require careful planning to address environmental and social concerns, ensuring sustainable development for the future. In the hill and mountainous regions, people traditionally built diversion channels known as gulls or kulls in the western Himalayas. These channels help divert water for agriculture, making use of the natural terrain. Moving to the semi-arid areas, particularly Rajasthan, rooftop rainwater harvesting was a common practice. Homes often had underground tanks connected to sloping roofs through pipes. When it rained, water would flow down these pipes and fill the tanks below. This stored water could then be used later, especially during dry periods or summers when other sources might dry up. Many houses in places like Bikaner, Falodi, and Barmer had these underground tanks, which stored what's called pure pani, or rainwater, considered to be the purest natural water. Now, given the challenges and opposition to large-scale multi-purpose water projects, rainwater harvesting emerged as a practical alternative. It's a solution that's both socioeconomically and environmentally sustainable. People in these regions possess deep knowledge of local rainfall patterns and soil types, which has helped them develop a wide range of techniques to harvest not just rainwater, but also groundwater, river water, and floodwater. These methods are carefully adapted to the local ecological conditions and meet specific water needs. So, in essence, rainwater harvesting isn't just a traditional practice. It's a vital, resilient strategy that helps communities manage water effectively, especially in water-scarce regions. Tamil Nadu has taken a pioneering step by making rooftop rainwater harvesting structures mandatory for all households across the state. This means every house is legally required to have a system in place to collect and store rainwater. There are also legal provisions to ensure compliance, with penalties for those who don't adhere to this regulation. Now, let's look at the Gendathar system, which is a great example of how effective rainwater harvesting can be. This area receives about 1,000 millimeters of rainfall annually. With an efficiency of around 80% and about 10 fill-ups a year, each household can potentially collect and utilize roughly 50,000 liters of water every year. That's a significant resource, especially in water-scarce times. Turning our attention to Meghalaya, here we see a different but equally impressive traditional system. For over 200 years, local communities have used bamboo pipes to tap into stream and spring water. The process involves about 18 to 20 liters of water entering the bamboo pipe system, which then transports the water over hundreds of meters. By the time it reaches the final site, the flow reduces to just 20 to 80 drops per minute. It's a simple, sustainable, and highly effective way of ensuring water access over long distances. Finally, let's briefly touch on the bamboo drip irrigation system. It's a traditional method that exemplifies how indigenous knowledge can be harnessed for sustainable water management, seamlessly connecting local practices with modern needs. These systems not only conserve water, but also reflect the importance of respecting and integrating traditional methods into our broader water management strategies.